Okay, now we're going to move on to multiplying. And before we work on multiplying our radicals, we want to go back over our rules of polynomials. And so we can see that it's, again, really the same exact thing. So here we have a polynomial, a monomial times a binomial. And in order to multiply these, we would have to remember what that's called, distribute. So we would have 3 times x, which would be 3x. And then we would have to say 3 times a positive y is a positive 3y. And then after we have distributed, our last step is always to see if we can combine any like terms. In this case, there are no like terms, so our answer would just be 3x plus 3y. Now, what happens if we had a binomial times a binomial? Well, we would do really the exact same procedure. We would have to multiply or distribute our first term throughout the second binomial. And keep in mind, when we're multiplying these things, here we have a 2x times an x. When we multiply 2x times x, we have to multiply the whole number parts, which in this case would be 2 times 1 to get 2. And then we have to multiply the variable parts, or x times x, which would be x squared. We want to keep that in mind because that's going to really be important with the radicals also. Then we would multiply the 2x times the positive 3, which would be positive 6x. And then we would have to distribute our negative 5 throughout the binomial. So negative 5 times x would be negative 5x, and negative 5 times positive 3 would be negative 15. Now remember, our last step is always to see if we can combine like terms, and in this case we can, because we have plain x terms that we can combine. So we have 2x squared plus 6 of those minus 5 of those would be plus 1 of those, and then minus 15. So this would be our final answer, just multiplying these polynomials. Okay, and then one last thing before we start in here. We have actually already multiplied radicals. We found when we were doing that all we had to do was multiply, and we could do it as long as the index was the same, and then we just multiplied the radicands together. So this became the cube root of 6 times 10, which is 60. And then our last step is always to try to simplify if possible. So we would have to think, is there any two things we could think up? One is a perfect cube that would go into 60, and in this case, no. So we could not simplify that any further, even though that's always our last step. We can't simplify any further, so this would be our answer. Okay, now we're going to take those ideas and we're going to put them together to learn how to multiply radical expressions. So here, if we didn't have radicals in here, if we just had numbers and letters, then whenever we see this multiplying in this parenthesis, normally we do think of distribution. Well, that rule does not change at all just because we're working with radicals. So here we need to distribute this radical 3, or square root of 3, times 2. Now again, just like when we were multiplying with the letters, if we had like the 2x times 3x, say something like that, we would multiply number parts and then letter parts. Well, we're going to do the same thing here. We're going to multiply whole number parts, so it's almost as if there's an imaginary 1 out here in front. So it would be like saying 1 times 2 is 2, and then we would have to multiply radical parts. Well, there's not 1 here. So that would just be 2 square roots of 3 when we multiply these two together. Minus, because positive times negative is negative. Here we've got the square root of 3 times 3 square roots of 2. Well, again, we're multiplying whole number parts, so this is technically a 1. So that would be 3, and then radical parts, square root of 6. And our last step is always to see if we can simplify any. We cannot break down the square root of 3. There's not a perfect square inside of it. And we can't do anything with the square root of 6. Again, there's not a perfect square inside of it. So since we can't combine anything, this would be our final answer.